let's talk about the difference between the dot product and projection. Some people are noticing there's some similarities in the formulas and there's a few questions, but let's just talk that through for a moment. So to start off, let's start by talking about the dot product. So remember, the dot product is just a value that tells us something about the angle between vectors. And we have this useful formula here, cosine theta equals the dot product of A and B divided by the magnitude of A times the magnitude of B. And what does this tell us? This gives us the cosine theta value that we can use to find theta. So we can imagine I have my graph here, x or theta, and y, and my cosine curve. And when I find this value, it gives me some y value. And I can then use that to find whatever my angle is. And that's basically what we've done already in class. Just label my curve here, cos theta. All right, and what's going on with projection? We do have our formula for the magnitude of the projection of u onto v. And that is equal to u dot v over magnitude of vector v. So we notice that this is kind of similar to our cosine theta, our dot product formula, but not quite the same. I have the dot product of the vectors on top. Here I have two magnitudes on the bottom. Here I only have one. So let's just put a few more pieces together and see if we can make a connection between these two things. We'll also mention that if we're finding the actual projection and not just the magnitude, projection of u onto v, basically we have the magnitude from our previous question. So u dot v over magnitude of v, and then we multiply it by the unit vector in the direction of v. So we have our v vector divided by the magnitude of v. And what does this information give us? It gives us this vector, and I'll draw that in a moment. So we have my vector u. They're drawn tail to tail. I have my vector v. And we're finding this vector right here. So that is our projection. So this, oops. So we're finding this vector right here. Let's kind of take a step back and let's take a traditional approach to what does it mean when we're talking about cosine. So we'll kind of talk about our triangle here. I'll sketch it down here. So traditionally, we know that cosine theta equals a over h. And let's label our triangle here. We have our h, theta's here, adjacent, opposite. And what else do we know is going on here? Well, my vector v is down here. So that's not just the length of my triangle, it extends beyond. My vector u is here. We'll call this h for height, just to label it something. And the other kind of piece that we would need here is the length of this side, which is going to be the magnitude of projection of u onto v for its magnitude. Or we can just call it, if this was a vector, it would be the projection of u onto v. All right, what do we know about cosine theta? It's equal to a over h in this specific case. Cosine theta is a. And what do we know about the value of a? Well, it's the magnitude of the projection of u onto v. And what do we know about my hypotenuse? Well, that's the vector u. What else do we know about this situation? Well, I know that the projection of u onto v is equal to this part right here. So let's sub that into our equation. So projection of u onto v is going to be u dot v over magnitude of v, and then divided by u and divided by, or actually we just want the magnitude, so the magnitude of vector u. So dividing is the same as multiplying by the reciprocal, so I'm just going to think of this as multiplying by 1 over u, and we can tidy this up a little bit. So cosine theta equals u dot v over magnitude of v, and then on the bottom here, magnitude of u. All right, cool. So we started from like our first principles. We just started. We started with our trigonometric identity. We had our wonderful labeled triangle here. We put those pieces together. And what did we find? We found that this formula here, does that look familiar? That's actually the formula we started with up here, just our labels are different. Here we have A and B at the top. Down here we have U and V. So they're the exact same formula. So what is the relationship between our cosine theta dot product thing here and our magnitude of our projection here? Well, the magnitude of the projection is just this part of our cosine theta formula. And then we're dividing by the magnitude of u in order to finish it up, because that's our hypotenuse. So I hope that made sense. I hope that just helped put a few pieces together in place for you. And if you do have questions, let me know during class.